In this video, we're going to talk about the different types of solving quadratic equations. And as you remember from previous lessons, that there are three ways of solving. We have factoring, we have completing the square, and then we have using the good old quadratic formula. So I've got two equations which will have imaginary or complex answers. And what I wanted to do is show the different methods that we can use. So first of all, we always know that factoring is a possibility, and the things we have to remember when we're factoring is that first of all we have to set it equal to 0, and then we have to factor the polynomial or the quadratic. Now the nice thing about this as we get on into further lessons is that when we are solving for other kinds of zeros or roots or solutions is that setting it equal to 0 and factoring is a wonderful thing when we have cubics or to the polynomials to the fourth power to the degree of 5 and so on and so forth. So it's always something that we want to look at. When I'm looking at these two quadratics here though, these are not factorable to whole integer answers. So these are ones that we're not really going to be applying these techniques right away. So what we're going to be doing is we're going to be going down to completing the square. So let's look down at these possibilities. Now the first thing we have to know is that we're going to have the x squared value or the degree 2 value, as well as the x term on one side of the equation the constant on the other side. So in this case, with this first equation, I've got x squared minus 6x, and then what we're going to do is we're going to take this positive 13 and I'm going to move it to the other side of the equation, of course subtracting 13 from this side and subtracting 13 from this side. Then what we have to do is we have to complete the square. We have to create a binomial squared. And to do that, we have to, let me get a different color. We take half of that center term coefficient, and then we square it. So we take half of the second term and then square to create the third term in our trinomial. So we've added 9 to this side of the quadratic equation, and then we have to make sure that we add it to this side. So what I've got now is we have 6, no we don't. We have x minus 3. That value here becomes the second term in our binomial. And then we combine our like terms over here. Negative 13 plus 9 is equal to a negative 4. And then what we do is we take the square root of both sides. So I'm going to take both sides. Oops. So let's go back to our values, and so we're going to take the square root of this side, and we're going to take the square root of this side. So the square root of any binomial squared is simply the binomial. And then the square root of this, well, we have the square root of a negative number, which will be our imaginary. So remember, this is going to be the square root of negative 1 and the square root of 4. So the square root of negative 1 is our I, and the square root of 4 is 2. And if we needed to simplify that more, we could. For example, if we try to take the square root of 8 or the square root of anything like that. The other thing to remember that when we take the square root of both sides, it is both representing the positive and the negative value. So when we do completing the square, we have to take the square root of both sides, but the answer represents the positive and negative value of both of the 2i. So then continuing to solve or isolating x, we're going to add the 3 to both sides. So my answer to that particular equation is 3. We can say positive negative, 2i plus 3 Gotta make sure to make my I look like an I. And that's going to be our final answer. So let's look at the second one. And we already have a situation in this one here where it's already binomial squared, so I don't have to do that kind of work. So that's great. But the thing is I have to take that 25 here and get it set on the other side of the equal sign. So I've got my x minus 5 is equal to negative 25. Again, add, oops, excuse me, I forgot the squared. X minus 5 squared is equal to a negative 25. And to solve that, see, we got to skip over that first side where we didn't have to complete the square. The square was already completed, so I'm going to take the square root of both sides. And so what I have now is x minus 5, and again, this is the square root of negative 1, the square root of 25, so this is going to be 5i. And I know the I was written first, but what we're doing is we're always writing that letter second, or that imaginary second. But the other thing to remember is that it's the positive and negative values of that term. And then to isolate x, what we're going to do is I'm going to add the 5 to both sides. Remembering again that you cannot combine your imaginary numbers with your real coefficients, real constants, excuse me. So you're going to say it's positive negative 5i plus the 5, and that's going to be your final answer. So what we're going to do lastly is we are going to do the exact same thing, but we're going to solve it using the quadratic formula. And if we've done this correctly, that means we should land on the exact same values, whether we solved it by completing the square or if we solved it by quadratic formula. So remember, the quadratic formula is our negative b plus or minus the square root of b squared minus 4ac, extend that there, all over 2a. And you notice that plus or minus, that's what's going to give us both of those values. So in this case, and we remember that a is the coefficient of x squared, b is the coefficient of x, and c is the constant on the other side. So let's look at this first one. When I'm looking at that, I have a is going to be this coefficient here, b is going to be this coefficient here, and c is going to be that constant here. So that's all nice and set up. Here's the thing we have to remember is that this has to be set equal to 0 before I start plucking out the a, b, and c. So we had from up above, and you might have to, I mean, I made it big so we can see it, but you might have to scroll back in the video. A was equal to 1, b was equal to negative 6, and c was equal to 13. So pause the video and put all the values into that equation. So here are all the values plopped in. One thing I want to point out is it says in the equation that the quadratic formula is negative b. That means when b is already negative, the value plopped into the equation is going to be positive. So I'm going to pause the video and work out some of the orders of operation. So I've done some of the order of operations, and I'm going to pause here just for a moment to show you that now I've worked it down here. And it's starting to look like the same answer we got here, but we're not quite there yet. So let's continue to do this. Remember, when we take the square root of the negative 16, I'm going to write that 6 there. And then again, that is the square root of 4 and the square root of negative, excuse me, square root of 16 and the square root of negative 1, which becomes 4i. And again, that's all over 2. And as a reminder that what we can do, we can't just cancel, I can't just do this, say, well, 2 and 6 cancel out because this top numerator is part of a polynomial. But what I can do is a shortcut way is putting both of them over the same denominator. So what I have now is 6 divided by 2, which is 3. And then I have my 4i divided by 2, which is 2i, which is exactly what we got here in a different order. But again, we still have the positive negative. Wonderful, wonderful, wonderful. So let's look at the second one. And again, we still should end up with positive negative 5i plus 5. So let's go back to the original, which said x minus 5 squared plus 25. So x minus 5 squared plus 25 is equal to 0. Now, we've got the thing set equal to 0. That's great, but I don't have it in the form of x squared, excuse me, ax squared plus bx plus c. So I got to expand that puppy out and figure out exactly what that should actually be. So I expanded out that binomial. Remember, it's not just squaring both of the value. That's x minus 5 times x minus 5. So I'm expanding that all out. So my actual equation is x squared minus 10x plus 50. So when I equals 0, of course that's important. And then what we have to make sure we do is we pick out that a from this thing that's been worked out. So a is 1, b is negative 10, and c is going to be 50. So pause the video and put those values in. So here's all the values plopped in, and let's do some order of operations. I'm going to pause the video and let that work out. So what I've done so far is done the order of operations, and once again I have the square root of a negative number, so they're going to be imaginary roots. Remember, both imaginary roots say that we are not going to actually cross the x-axis. The graph is either floating above or it's inverted and it's below. Hopefully we know that it's floating above because our coefficient of x is positive, but that will be another video. So we have the imaginary number, and once again what I'm going to be doing is I'm going to be reducing this down. So what this means is I can take the first term over the denominator, and that should be a plus or a minus, forgot that little guy, and the second term over the denominator, which reduces down to 5 plus or minus 5i, which again is what we got here. So remember that we have all these different tools at our disposal, but you have to make sure that no matter what you use, that you get the exact same answer. Got more questions? Email me and I'll help you out.